In this video, we're going to look at the laws of exponents. So the first one talks about multiplying exponents. As you can see here, we have the problem 5 to the 6 times 5 to the 4th power. So what I've done on the next line is I've broken down what 5 to the 6 and 5 to the 4th mean. 5 to the 6 means we have 5 times 5 times 5 times 5 times 5 times 5. We have 6 5s, right? And 5 to the 4th means 5 times 5 times 5 times 5. So when I write these two problems next to each other, I just see a bunch of 5s, right? How many 5s are there? Well, there's 10 5s. So this problem is really just like doing 5 to the 10th power. And that's because when you're multiplying, as long as the bases are the same, you're allowed to add the exponents as a shortcut. So in this question, 5 to the 6th times 5 to the 4th is the same as 5 to the 10th. In both cases, we have 10 5s that are being multiplied. The next law deals with dividing exponents. In this example, we have 7 to the 8th power divided by 7 to the 5th power. So in my numerator, I wrote 7 times itself 8 times. And in the denominator, I have 7 times itself 5 times. Now think back when you learned fractions. You learn that when things are in the numerator and the denominator, and they're the same, and they're all being multiplied, you can cancel them out because anything divided by itself is 1. So in this fraction, we have some 7s in the top and the bottom, so those blue lines indicate 7s that can cancel out. If I do 7 divided by 7, it's 1, right? And multiplying by 1 doesn't do anything. There's actually 5 7s in this problem that can be canceled out. Well, there were 8 7s in the numerator, and there were 5 7s in the denominator. Altogether, we ended up really with just 3 7s in the whole problem. And as at the end, you can see that I just have 7 to the 3rd power. So the shortcut here is that when you're dividing exponents, you can subtract the exponents as long as the bases are the same. So 7 to the 8th power divided by 7 to the 5th power is really just 7 to the 3rd power. And the last law we're going to look at is exponents raised to exponents. So in this example, I have 4 to the 5th power in parentheses, and it's being raised to the 3rd power. So we know an exponent means to multiply something by itself some number of times. And in this case, we're going to multiply 4 to the 5th times itself 3 times. 4 to the 5th times 4 to the 5th times 4 to the 5th is me just multiplying it by itself 3 times. And then each parentheses is 4 to the 5th, so why don't I write it out as 4 times 4 times 4 times 4 times 4? And I did that for each 4 to the 5th, and then this just goes back to what we saw earlier. When you have a bunch of 4s being multiplied or a bunch of x's being multiplied, just count them all up, and that's what exponent you can use to shortcut this. So 4 to the 5th power, in parentheses, raised to the 3rd power, is really just 4 to the 15th power. So our shortcut here is that when you're raising an exponent to another exponent, you can multiply those digits. You can multiply those numbers. 5 times 3 is 15, so this problem really is just 4 to the 15th power. So that's the laws of exponents. We're going to learn a couple more in a few days, but for now, use these 3 laws to practice the Delta Math assignment that I've given you.